Hi everyone, I'm Miss Elise giving you the part 2 of normal distribution. Herein is statistics and probability. So let's introduce first the learning competencies. The learner shall be able to convert a normal random variable to a standard normal variable and vice versa. Next, computes probabilities and percentiles using standard normal table. So let's proceed to our topic for today. As we discussed in the previous section of normal distribution, the area under the standard normal curve can be determined using the z-table. However, in reality, a continuous random variable may have a normal distribution with value of a mean and standard deviation from 0 and 1 respectively. This normal distribution must be converted to a standard normal distribution. This procedure is called standardizing a normal curve, and this will be our discussion for today. In standardizing a normal curve, we will use this formula. Z-value is equal to the difference of the value in the mean divided by the standard deviation, because all normal distributed variables can be transformed into a standard normally distributed variable. This is a z-table, as what I discussed in the previous video about normal distribution in finding areas under the standard normal curve. So let's have a short recap. Entries in the table given the area under the curve between the mean and the z standard deviation above the mean. So how will we find the area under the curve given the z value? Let's follow these steps and reminders to find the area of a given z value. Let's have an example. And I have here z is equal to 1.62. Most of the time, z value has 3 digits. To know the area, first is determine the first 2 digits of the z value and locate it on the leftmost column. In our given, the first 2 digits are 1 and 6, and it is located here. In the second step is to determine the third digit of the value and locate it to the topmost row. The third digit here is 2, and it is right here. The third step is to find the intersection of the values from step 1 and 2. So the intersection here is 0.4474. This is already the area between the given z value and the mean. For us to find the normal probability, just multiply the area by 100%. So the normal probability of 1.62 is 44.74%. Did you get it? If you are able to remember this, we will use it later. Again, this is the summary of the different situations that may appear when asked to find the normal probability. I have here 5 situations. The first situation is between 0 and any number. So you just need to look for the area for the non-zero value in the table. The second situation is between two values with same sign. You need to look for both areas in the table and subtract the smaller from the larger. The third situation is between a negative and a positive. You need to look for both areas in the table and add them together. For the fourth situation, less than a negative value or greater than a positive value. You need to look for the area in the table and subtract from 0.5. And last situation will be greater than a negative or less than a positive. You need to look for the area in the table, then add 0.5. So let's have an example. For example number 1. We need to determine the z-value from each of the following x values from normal distribution with a mean of 16 and standard deviation of 4. The value of our scores are 13, 24, and 16. So starting to use the formula, we have for the set A, we have the given score is equal to 13, the mean is equal to 16, and standard deviation is equal to 4. And this will be our formula. Substituting all the given to our formula, we will have 13 minus 16 divided by 4 is equivalent to negative 0.75. So the z-value for letter A is negative 0.75. For the set B, we have given score is 24, the mean is 16, and the standard deviation is equal to 4. Substituting all the values to our formula, we will have 29 minus 16 over 4 is equivalent to 2. So the z-value for set B is 2. For the set C, we have a given value of score is equal to 16, mean of 16, and a standard deviation of 4. Substituting all the values to our formula, we will have 16 minus 16 divided by 4, so z is equal to 0. So these are the example for our number 1. For letter A, we have z is equal to negative 0.75. For letter B, we will have z is equal to 2. For letter C, we will have z is equal to 0. To find the area between two values of x for the normal distribution, convert first the values to x to their corresponding z values. The area between the z values gives the area between the corresponding x values. Let's try another question. So this is our example number 2. For continuous random variable that has a normal distribution with mean of 20 and a standard deviation of 4, find the area under the normal curve from given score 20 and another score is equal to 28. So let's find out for its solution. So these are the given. So we have the first value of score is equal to 20, the mean is equal to 20, and the standard deviation is equal to 4. First, standardize the normal distribution by converting the x values to z values. So substituting it to our formula, we have 20 minus 20 over 4. The first z value is equal to 0. For the next value of x, we have score is equal to 28, the mean is equal to 20, and the standard deviation is equal to 4. So substituting all the values, we have 28 minus 20 over 4. The z is equal to 2. So we got 0 and 2 here. Then looking at the z table for its area, so getting the area between z is equal to 0 and 2. So we just need to look for 2 and 0.0. Getting the intersection of 2, the area is equal to 0.4772. So the answer is, therefore, the area under the normal curve between a given score 20 and a second score is equal to 28 is 0.4772. We don't need to multiply it by 100% since we're talking about the area of the normal curve. So let's have another example. A brisk walk at 4 4 miles per hour burns an average of 300 calories per hour. If the standard deviation of the distribution is 10, find the probability that a person who walks 1 hour at the rate of 4 miles per hour will burn the following calories. Assume that the variable is normally distributed. For the set A, we have more than 270 calories. For set B, we have less than 318 calories. And for the set C, we have between 270 and 318 calories. So let's solve for it. To solve this problem, we need to transform first the values of the variables in z values. Using the mean is equal to 300 and standard deviation of 10. For set A, we have more than 270 calories. So using the formula, we need to substitute all the values. We will have 270 minus 300 divided by 10. So using your calculator, we have negative 3.0. For set B, we have less than 318 calories. So substituting it to our formula, we will have 318 minus 300 over 10. We will have z is equal to 1.8. And for letter C, we have between 270 and 318 calories. Since we got the answer from letter A and letter B, we will put it z sub 1 as negative 3.0 and z sub 2 will be equivalent to 1.8. So we need to determine each probability. Look at the area in the z table. And we are going to use some situation that may arise when asked to find normal probabilities. And it is number 5. So we have here greater than a negative. So what we're going to do is to look for the area in the table, then add 0.5. Therefore, the given probability, which is greater than negative 3.0 or more than 3.0, we will have 0.5 plus 0.4987. We will have a given which is 0.9987. So the probability more than negative 3.0 is equal to 99.87%. Then we need to determine the probability. So we need to use some situation that may arise when asked to find probability. And it is also number 5. So we have here less than a positive. Then we need to look for the area in the table, then add 0.5. Therefore, the given probability of z less than 1.8 is equal to 0.5 plus 0.4641. We will have 0.9641. So the probability less than 1.8 is 96.41%. And for the set C, we need to determine the probability. So we also need to look for the area in the z table and use the sum situation that may arise when asked to find normal probabilities. And it is between two different sign number. So we look for both areas in the z table and add them together. Therefore, we will have a probability between negative 3 and 1.8 will be equivalent to 0.4987 plus 0.4641. So we will have 0.9628. Therefore, the probability between negative 3 and 1.8 is 96.28%. Again, I am Miss Elise for Statistics and Probability. Thank you for watching. Please like, subscribe, and share. MATHerrific, learning materials for math and physics.